Hello, anatomy students. We're now ready to review for our test over the cardiovascular system. For this particular test, I want to tell you that there's going to be 20 multiple choice questions. There will be a fill in the blank question that will involve how blood flows into the heart and then out into the body. I will, of course, give you guys a word bank for that. And then also there's going to be two diagrams. So we have an electrocardiogram and then the diagram of the heart. So notice for this particular test, there is no short answer questions. And so let us go ahead now and get started with the first question on the review sheet. What are the components of the cardiovascular system? That would be the heart, blood, and blood vessels. Number two, the pulmonary circuit is what sends oxygen-depleted blood to pick up oxygen and unload CO2. So again, we breathe in oxygen and we breathe out CO2. And so again, because it involves our lungs, we know that this is the pulmonary circuit. So pulmonary always refers to the lungs. The systemic circuit, if you look at the word, it has the word system up front. This is going to send oxygen-rich blood and nutrients to all the body cells and removes waste. So again, these are the two major circuits within your cardiovascular system. All right, number three, briefly describe the size and location of the heart. The heart is a hollow, cone-shaped muscular pump. It lies within the thoracic cavity and rests on your diaphragm. And so remember again, your diaphragm is your muscle underneath your lungs that help you to breathe in and out. Also want to point out that the heart's distal end, the far end of the heart, extends downward and to the left. So again, it's going to be kind of pointing in this general direction. All right. We're going to look now at different types of heart tissue. We have the pericardium. So peri is the one that the covering encloses the heart. And then we also have a pericardium cavity. This lies between the epicardium and the pericardium, and its main function is to prevent friction between them. So your heart obviously needs a place to contract and relax, and so the pericardium cavity provides an opening for it to open and close without having to deal with friction. All right. Epicardium, so remember epi means upon. This is the outermost layer of heart tissue that protects the heart by reducing friction. Myocardium, again, when you think of myo, think about muscle. And so the myocardium is the thick middle layer that is mostly cardiac muscle, which pumps the blood. So this is obviously the thickest part of the heart tissues. And then on the inside, of course, we have the endocardium. And so this contains fibers, blood vessels, and the ever so popular Purkinje fibers. Next, we're going to describe the two types of heart chambers. On the top, we have the atria, which is the plural of atrium. These are the upper heart chambers that have thin walls and receive blood returning to the heart. And the reason the walls are thin is because it's only pumping blood down to the lower chambers of the heart, which are the ventricles. And so the ventricles will receive blood from the atria, and they contract to force blood into arteries. So the walls here obviously have to be much, much thicker because, again, you're trying to force blood through your blood vessels using pressure. All right. For number 7, you're going to describe the path of blood through the heart, listing the important chambers, blood vessels, and valves involved. So again, this is going to be the fill-in-the-blank portion of the test. I'm going to go ahead. I will give you guys the word bank to go along with that. You'll use each word just once. I'm going to go ahead and remind you what those steps are over here. And so, first of all, blood that is low in oxygen and high in carbon dioxide goes through the superior vena cava and inferior vena cava. So again, don't worry about the numbers. It's just referring to the figure previous to this slide. And it enters the right atrium. All right, so for example, I might have on the test, blood that is low in O2 and high in CO2 goes through the blank and enters the blank. And so you would have to put down superior vena cava, inferior vena cava, and then the right atrium. So those would be kind of like the fill in the blanks I'm talking about. All right. The right atrial wall will contract. The blood passes through the tricuspid valve. So remember, tricuspid means 3 points, and enters the right ventricle. Next, the right ventricular wall contracts. Blood passes through the pulmonary valve, which again, when you think about pulmonary, you should be thinking about your lungs, and through the pulmonary arteries to the lungs where CO2 is exchanged for O2. And so remember, this is the only exception to the arteries, veins thing. So the arteries normally carry oxygen-rich blood to the parts of the body. The veins are taking the oxygen-depleted blood back to the heart. In this case, the pulmonary arteries are taking blood to the lungs, and the pulmonary veins are doing the opposite. So it's the only exception to that rule. All right, freshly oxygenated blood returns to the heart through the pulmonary veins and enters the left atrium. The left atrial wall contracts. The blood passes through the mitral valve, which is also called the bicuspid valve because, again, it has 2 points, and into the left ventricle. Finally, the left ventricular wall contracts. The blood passes through the aortic valve. Remember, the aorta is the largest artery of your body, into the aorta and its branches. And so then it'll go out to the body. It'll exchange the oxygen for CO2, and then it'll start back over up here at the top. So it is, in fact, a cycle. All right. Okay. All right. We're going to continue on. Systole is a contraction. Diastole is relaxation. And so if the atria is contracting, then the ventricles are relaxing and vice versa. All right. When you talk about heart sounds, you have the characteristic lub-dub, lub-dub, lub-dub. The lub sound comes from the atrioventricular AV valves closing tightly. The dub, the second sound, comes from the semilunar valves, which are then closing. So the AV valves would be your tricuspid and mitral or bicuspid valve, and then the semilunar valves are your pulmonary valve and your aortic valve. And so they slam so hard and so tight that you physically hear them, and that is what causes your heart, the lub-dub, lub-dub. All right, number 10. Asks to draw a diagram to illustrate the cardiac contraction system. And so what we have, the pacemaker of the heart is the sinoatrial SA node. And so this is going to trigger the AV node. This is going to trigger the AV bundle. This is going to activate the Purkinje fibers. And then these are going to lead then to a ventricular contraction. And so that is how the cardiac conduction system works. All right, number 11. What part of the nervous system controls both heart rate and rhythm? It should come no surprise to you that is, in fact, the autonomic nervous system, the ANS, because, again, you don't have to actively think about it. And so, therefore, it's done for you automatically. All right. Number 12, acetylcholine is the hormone that's used in the regulation of the impulse conduction of the heart, and it's norepinephrine that is used then by the sympathetic postganglionic neuron. So 2 hormones that we already discussed previously in the endocrine system. All right, we're going to go ahead and list and describe the 5 blood vessels. We have our arteries, which carry oxygen-rich blood and nutrients to the tissues. The arterioles are thinner arteries that merge with the capillaries. The capillaries, as you remember, are the smallest of the blood vessels. This is the place in the body where gases, nutrients, and metabolic byproducts are exchanged. We also have venules, which continue from capillaries and merge with veins. And then we also finally have veins, which will then carry oxygen-depleted blood back to the heart. And so those are the 5 major types of blood vessels. All right. Vasoconstriction is when the blood vessels tighten and therefore you're going to have a decrease in heat loss. And so this is probably going to be used in the wintertime. Vasodilation is when the blood vessel opens up, which will result in increased heat loss. And so you would see this then during the summer months when it's hotter out and you want to try to cool your body. So it will open up the blood vessels to release the heat in order, of course, to maintain body temperature homeostasis. All right. Number 15. Systolic pressure is the maximum pressure during ventricular contraction. Diastolic pressure is the lowest pressure that remains before the next ventricular contraction. And both of these pressures are measured in millimeters of mercury. So it's a unit of pressure. And so a normal blood pressure, again, is 120 over 80. So the 120 is the systolic pressure in millimeters of mercury, and the 80 is the diastolic pressure, also in millimeters of mercury. So your normal blood pressure should be 120 millimeters of mercury over 80 millimeters of mercury. All right. What factors influence arterial blood pressure? We have blood volume, effectiveness of the heart as a pump, resistance of the system to blood flow, and distribution of blood between the blood vessels. All right. Also wanted to remind you that there will be a diagram of an ECG on the test. And so again, if you're curious, this is the ECG. I would have these labeled for you, but then you basically have to identify each of these parts of the ECG and then give this brief definition for each of those. And so that'll be one of the figures on the test. And then finally, the last figure, of course, will be this figure of the heart. And so again, I would give you guys a word bank. It would be a one-to-one type thing, and therefore that would be the heart diagram that you'll be filling out for that. All right, and so with that, we are now done reviewing for the cardiovascular system. I hope you guys have a good rest of your day, and I will talk with you guys again soon.